Imagine a time before the internet, before smartphones. 1977. Humanity built a ship not for oceans but for the vast darkness of space. Voyager 1. Small, robotic, and lighter than a car, its mission was to explore the outer solar system and then journey on, forever. On September 5, 1977, a Titan rocket launched Voyager 1 from Cape Canaveral, breaking free from Earth's gravity. We hurled a machine with such precision that it would fly past worlds no human had ever seen. This was more than engineering. It was hope and courage, a leap into the cosmic dark. The real journey was the silent, lonely voyage through space, facing radiation, micrometeoroids, and the cold. Its power source, fueled by radioactive decay, was built to last decades. Voyager was a messenger, carrying our story to places we could only imagine. Its mission: to learn, to see what was out there, to answer the questions we've always asked while gazing at the stars. Are we alone? What are those distant worlds like? Voyager 1 became our eyes and ears, extending our senses billions of miles from home. It was more than a machine. It was our curiosity, venturing into the darkness so we could be illuminated by new knowledge. The journey had begun, and the universe was waiting. We sent a messenger on a quest that would outlast its creators. Voyager's launch was just the beginning. The adventure into the unknown had started. Voyager 1's mission was possible thanks to a rare planetary alignment. Jupiter, Saturn, Uranus, and Neptune lined up for a cosmic slingshot. This grand tour let a single spacecraft visit multiple worlds, saving decades of travel. Voyager 1 and its twin, Voyager 2, were designed to seize this fleeting chance. Their mission: pure exploration. Voyager 1 carried cameras, spectrometers, and magnetometers, a roving lab to observe, record, and transmit discoveries. Each bit of data turned points of light into real places. The journey was a chain reaction. Jupiter's gravity would fling Voyager to Saturn, and so on. NASA's engineers choreographed every maneuver with precision. A tiny error could mean missing everything. The goal wasn't just flybys, it was a detailed survey of weather, moons, rings, and magnetic fields. Could any moons harbor life? What were these giants made of? Voyager 1 was our scout, pushing the boundaries of what we knew. It was sent to explore, discover, and change our perspective on the solar system. This was exploration on the grandest scale. In 1979, Voyager 1 reached Jupiter, and what it revealed was breathtaking. The Great Red Spot was a massive hurricane, wider than 3 Earths, raging for centuries. Jupiter's bands were jet streams of ammonia clouds swirling at hundreds of miles per hour. Voyager's cameras found active volcanoes on Io erupting, reshaping the moon's surface. For the first time, we saw another world alive with geological activity. The outer moons weren't dead rocks, they were dynamic, each with a story. In 1980, Voyager 1 arrived at Saturn, revealing its rings as thousands of icy ringlets, not solid bands. It discovered spokes in the rings and tiny shepherd moons shaping them. Voyager gave us our first close look at Titan, Saturn's largest moon, with a thick, nitrogen-rich atmosphere denser than Earth's. Titan's haze hinted at complex chemistry, maybe even methane rain in rivers. Each discovery rewrote our textbooks and expanded our cosmic perspective. Voyager's postcards from the giants showed us a solar system more alive and complex than we'd ever imagined. The universe was stranger and more beautiful than we thought. By 1990, Voyager 1's main mission was done, but Carl Sagan had one last request: turn the camera homeward. From nearly 4 billion miles away, Voyager snapped a photo. Earth, a pale blue dot in a sunbeam. That tiny speck was home to everyone who ever lived. The image is haunting, forcing us to confront our place in the cosmos. It's a humbling perspective. Science at its best. Sagan said it best. This image underscores our responsibility to deal more kindly with one another and to cherish the only home we've ever known. From Voyager's vantage, our conflicts and borders vanish. The pale blue dot is more than a picture. It's a portrait of ourselves. It reminds us that our world is fragile, and our shared identity matters more than our divisions. The deepest value of looking outward is that it forces us to look inward. Voyager's final photograph is its most enduring legacy. It's a silent sermon on humility and unity. The universe is vast and we are small, but together we matter. Voyager 1 wasn't just a probe, it was a messenger. Attached to its side, a golden record, a time capsule for any distant civilization that might find it. The odds of discovery are tiny, but we sent it anyway because hope matters. The record holds 115 images, greetings in 55 languages, and the sounds of earth, wind, rain, animals, a mother's first words. It carries music from Bach to Chuck Berry, and traditional songs from around the world. Even if aliens never find it, the act of sending it says everything about us. The Golden Record is our attempt at immortality, a piece of our art, science, and love, sent on a journey that could last billions of years. Long after Earth is gone, Voyager's record will still sail the Milky Way. It's a message: we were here, and we cared enough to reach out. The Golden Record is the most human part of Voyager's mission. It's a legacy of hope, curiosity, and connection. In the vastness of space, we dared to say hello. Decades after its planetary encounters, Voyager 1 kept going toward the edge of the sun's influence, the heliopause. On August 25, 2012, more than 11 billion miles from the sun, Voyager crossed into interstellar space. Solar particles dropped off, cosmic rays from distant stars surged. Voyager became the first human-made object to enter the space between stars. Now, it samples the pristine material between star systems, measuring interstellar gas and magnetic fields. The data isn't flashy, but it's precious, our first direct taste of the galaxy beyond the sun. Voyager's journey into interstellar space is often overlooked, but it's groundbreaking science. It tells us about the environment our solar system travels through. Even in old age, Voyager is our first interstellar scout. Its mission continues long after its original goals were met. The cosmic ocean is vast, and Voyager is our first explorer. We are now truly a spacefaring species. Today, in 2025, Voyager 1 is nearly 48 years into its journey, over 15 billion miles away. Its radio signal is a faint whisper, taking over 22 hours to reach Earth. Its power is fading. Soon, its instruments will fall silent. But Voyager's final message isn't a single photo or data point. It's the story of its journey. It proves we can build machines that last half a century in the harshest environment. We can reach for the stars. Voyager is a monument to long-term vision, patience, and curiosity. Its greatest lesson: some achievements aren't for immediate gain, but for the pursuit of knowledge. Voyager teaches us to think on cosmic timescales, to invest in exploration for the sake of the human spirit. When it finally falls silent, it won't be an ending. Voyager will drift through the Milky Way for millions of years, carrying its golden record. Its legacy is inspiration, a symbol of when we dared to look beyond ourselves. The echo of its distant voice will resonate as long as we remember to listen.